with students is about 4,300 people, or thereabouts. So that's the overall population of Hamilton. If we wanted to actually know something about Hamilton, say we want to know the average age of residents of Hamilton, or something simple like that, we could go to every person in Hamilton, we could ask them their age, add them up, and divide by that number, and we get the average, right? We don't really have to do that, though, because if we talk to enough people in town, we can actually, as long as we actually have a good representative sample of the population of Hamilton, we can actually talk to a smaller sample, a proportion of the people in that population, and use that information to represent the overall population. So most social science research does this approach. They don't talk to everybody, which would be a census. We do this every 10 years in the US, right? We try to talk to every single person in the whole country and count them all up and find out some characteristics about them. That's a lot of work. Census costs a lot of money, takes a lot of people power. What we usually do is we take a shortcut where we say, let's take a subgroup of those people in the population and let's just talk to them and use them to represent the overall population. That's what sampling is about. It's trying to figure out what is that group of people that we want to talk to. And you can see that the key thing we have to be careful about, and I already used this term, is does the sample actually accurately represent the population? When we take that shortcut, that's what really is a risk of ours, is saying, well, if we took that shortcut and it turns out that the people in the sample don't look overall like that population, we might be in trouble in some way because we're missing some people, and then our sample would not be an accurate representation of the population. Overall, what we're trying to do then is figure out a way to get that group of people so we don't have to talk to everybody, and we can find out some answers to our questions. So typically, the number of people we want to talk to is represented with this variable n. So every time you see n equals, that's the sample size of a particular study. So say we were going to study Hamilton, we wanted to get the average age of people in the town, and we decided that we wanted to sample 100 people. We're going to ask them a question, what's your age? And then we're going to take those numbers, add them all up and divide by 100, and we're going to say, we estimate the average age of people in Hamilton to be based on those 100 people we talked to. That's where we would get. And so basically, if we think about our sample size n, the bigger it is, the more confident we're going to feel about the representatives of our sample. Right? If we talk to 100 people, we'd say, okay, well, what if those 100 people, because in Hamilton we have so many students, we know that averages are really affected by the weight of the data. So all the students in town who are roughly between 18 to 22 years old are really going to drag that average down, right? So what if it happens if all the people we talk to in the sample, 90 of them are students? That could very well happen that we did it a certain way to be all students, right? Well, then we wonder actually how representative our sample was of the overall population. We want to be careful about that. Maybe we decide we want to talk to more. We want to talk to 500 or talk to 1,000. So there's always a trade-off between how many people we talk to and the cost and effort that it takes to talk to those people, bumping up n, and how representative our sample is. Okay, so ideally we want to talk to as many people as possible, but that often takes more time, money, effort, and so forth. Okay, so when we're doing sampling, then there's basically two main types of samples that we can do: randomized and non-randomized. Okay, and typically when we're doing quantitative research, especially doing a survey of some sort, like this one with Hamilton residents, we will want to do a randomized sample. And one thing we have to be careful about to remember is that the way we're using randomized here doesn't necessarily mean random in the way we use it in our everyday kind of language, where we say, oh, that's so random. Like if somebody does something, your friend, oh, you're so random, or something like that, right? What does that mean? It's like, where the hell did that come from, right? That's what you mean by that. And that's not what we mean by a randomized sample. What do we mean by a randomized sample? Anybody taken a stats course before we learned about this? What does it mean actually when we say a randomized sample? That we're just doing whatever and it doesn't matter? No? Come on, you're a math econ major. You must have come across this before.
It's like mathematically generated write a computer program where all the possible people are in there and say, pick 5. The computer gives you 5 names, and then you have to list them.
Right, so you're choosing those 5 people at random, right? And what does it mean that if we have those people's list in the computer and we're choosing 5 at random, what's the special thing about the randomness of our selection there?
Your personal biases aren't affecting you.
That's right. So hopefully we're not biasing in some way, right?
Could you just repeat it?
Yeah, she's saying.
Oh, I said your personal biases wouldn't affect who you choose.
Right. Hopefully that's the case, right? And even further than that, what we usually mean by a randomized approach is that everybody in the population has an equal chance of being selected into the sample. Okay? So imagine if we're rolling a die. It's got 6 sides. If it's a fair die, randomly we would expect any of the 6 sides to come up with an equal chance on any given roll, right? That's what we're saying about our sampling process here. Anytime we pull people out of the population, everyone has an equal chance. So it's like this population is a box. And it's filled up with tickets. Everybody in Hamilton has a ticket. So I'm pulling a ticket out of the box, and everyone in Hamilton has an equal chance of being selected. That would be a randomized sample. So it's different than saying, oh, it's just random. That's what I mean, this distinction between random and haphazard. We're not doing something that's haphazard. We're doing something that's based on probability theory. And that's the basis for why we actually have we can feel good about our sample when we're doing a randomized approach like this. So again, especially for when we're doing survey research, randomized sample is kind of the gold standard. That's what we want to have to really feel good about the representativeness of our sample. Okay? Typically, we want to have at least 50 cases for doing a quantitative project like that. The statistics usually don't work that well when we have really small numbers. And 50 itself is even kind of on the low side. But 50 would be the bare minimum we'd ever want to do any kind of statistical analysis. Aside from things like averages or medians or range or standard deviation, we could do that kind of stuff. But anything beyond that, like t-tests or whatever, if you've ever taken a stats class, you probably would never do that on less than 50 cases. There's a math professor in the back, so she can correct me if I'm wrong, but
You're the one who uses it.
So then the other type, again, is everything else. Non-randomized approaches are ones that are not based on probability theory. And we use other techniques, and these can be useful in certain situations. So then sample frame is basically where we get our list of people from. So oftentimes it's just a list, like a directory or a membership list, something like that, that we can pick people off the list. So where we get that list of people that are in the computer you mentioned before, maybe we've got a list of all the students at Colgate. We've got a list of all the people who live in Hamilton because we have census data on them, or the village keeps some kind of records, or through the phone directory, something like that. Sample frame is usually what we use to make our sample and choose people from for that. Okay? So a couple sampling strategies. Randomized techniques, we have a couple we can use. A simple random sample would be what, sorry, what's your name again?
Kenzie.
Kenzie said before, if we had everyone's name, we put it into a computer, we use the computer to draw at random, like from a box. That would be called a simple random sample. If we've got everybody's name and we go to the trouble of putting them in the computer like that, we can do that, although typically that's not often how randomized samples are done. A more common way would be what we call a systematic sample, where we have that list, maybe it's the Colgate directory, and the way a systematic sample works is you take every nth or ith, or however you want to say it, person on the list, and you choose them into your sample. So like if we had a list of all the people in Hamilton, we wanted to sample 100 people out of 4,300, we could then divide those numbers into each other, and we take every person down the list who fits that pattern. Okay, so say, to make the math more simple, we have 100 people in the box and we want to sample 10, we would take every 10th person on the list, right? So that would be a systematic sample, and that's a pretty common way, especially if we have a random start. We start at a random point on the list, and then we go every 10th person or every 15th person or whatever it takes to get our sample. You can actually go to this cool website. Well, cool, it really depends on your definition of cool, whether you think this is cool or not. Probably I would guess maybe you don't think it's cool. I think it's pretty cool. It's called random.org, and it helps you generate random numbers for you for free. So if you ever have need for random number generation, you know where to go. Okay? So those are randomized samples. Non-randomized samples, these are ones we typically use for more of a qualitative approach, would be things like a convenience sample. Say I wanted to distribute a survey to Colgate students, and I had it with me today, and I just gave it to everybody in the room here. I said, okay, here's my survey, I'm going to give it to you all, fill it out, and then I use the results to say something about Colgate students. What do you think of that approach? Why not? She says a sample wouldn't be representative. I said, why not?
You'd have a bias for math students or
That's right.
students interested in social science.
Yeah, that's right. You could have all kinds of ways in which this group is not representative of Colgate students. Mostly AMS students, mostly students willing to be here on a Friday afternoon and listen to me drone on about social science research, things like that that make you out of the norm, basically. So all kinds of ways in which you would not be a representative sample, but you'd be a convenient sample. Same thing if I stood outside the coop and I had a survey about student attitudes towards whatever issue, and I said, hey, fill out my survey, and just whoever was walking by, I gave it to them. That would be convenient, but it would be limited, and it would certainly not be a randomized probabilistic sample. So that's kind of the lowest of our choices. That's probably the lowest on the food chain in terms of what we want to use for sampling, the convenient sample. But if it's the best we can do, sometimes that's what we do.